Antenna magic. When I originally had the idea of this antenna, I had in mind the Yaesu ATAS-26 because I expected that it would now have arrived in the UK, and I wanted to experiment with an antenna which I was hoping would work without the need for an antenna matching unit. So it would be ideal for the ATAS-26 without its optional antenna matching unit. Well, in actual fact, the ATAS-26 hasn't arrived yet in the UK. I suppose the good news is that there have been 1 or 2 firmware updates to the American version, and we shall benefit from those updates already being uploaded into the European version. And also it probably explains why we didn't want to take deposits very early on in the announcement of the ATAS-26, because it's very embarrassing to take deposits and then find that the radio hasn't arrived, and some people will think, well, I don't know, I'm not sure whether I want it now, etc, etc. So that's one of the reasons why we refrain from taking early deposits, because it can cause a little bit of frustration. There we are. Anyway, because the ATAS-26 hasn't arrived, I will continue with this video, but using something else. If you're like me, you like to mess about with antennas, then this short video may interest you. It all started with me taking another look at the ATAS-25 from Yaesu. The ATAS-25 is a portable antenna. It's rated 100 watts. It'll go from 10 meters through to 40 meters. And it's got an adjustable coil, a telescopic coil. It's like what they call a screwdriver, really. You can rotate it if you want to adjust it very finely, or you can slide it up and down. And I did a video on it, and it works well. I was very pleased with it. But I thought about what's the best way of mounting this? Now, the base has got a fit-in for a standard camera tripod, and you could put it on a tripod. The only trouble is that if you haven't got a tripod, tripods don't come that cheaply, and the cheap ones are quite lightweight, and this got a little bit of weight to it. So I thought, well, you need to spend a bit more money on a camera tripod, but you don't need a tripod or camera tripod, because you don't need to adjust the angle of this antenna. You just want it to be vertical. So take a look at this, which is a lighting tripod. It's a tripod used for supporting lights, and you can buy these very cheaply, about, I don't know, £10–15 on Amazon. And they've got a fit-in on the top, which just happens to be the same size as a camera fit-in. It's a threaded section there, and this is the basic concept of it. It's got a nice. I probably can't get probably too close to the camera actually, but basically it's got a nice base. It spreads out really nicely, and it means to say that it's an easy way to support this ATAS-25. And the ATAS-25, by the way, has got the 3-section whip. They screw together, and I think these are 3 sections there, and I think when it's finally assembled, it's nearly 2 meters tall, so it's not bad size. Covers, did I say that? It covers, yes, I think I said it covers 10 to 40 meters. So the idea was to mount it on the thread there. And there we are. I've mounted the antenna on the lighting stand, and that lighting stand is telescopic. I think the stand goes up to about 2.5 meters. So it means to say you could actually get this antenna easily in the air on a lighting tripod and be ready to operate. But like a lot of things, when I messed about with antennas, I discovered something else, something rather interesting, and I want to take you through it now, because it may give you some ideas on operating portable, even operating from a very small garden, or even operating as... I did these tests actually in my conservatory, and I put out some CQ calls on RBN, reverse beacon network, and I got some encouraging reports on 20 meters. So let me take you through what I was doing and what I discovered. So it got me thinking, a vertical needs some sort of counterpoise or radial system. And as the lighting stand is all metal, would that act as a counterpoise or vertical, call it what you like? And could I resonate the antenna just using the metal stand? Well, I was in two minds, and there was only one way to find out. I thought, oh, I'll give it a try and just see what happens. One of the most useful instruments that I have when I'm doing antenna testing is the zoom, the Rig Expert zoom. It's an absolutely fabulous bit of gear, saves so much time. You can do in a matter of a few minutes what otherwise would take much longer, because you can actually work at the feed point of the antenna. So yeah, zoom antenna or the Rig Expert is well worth having. Now this is the test setup to see whether my idea works. I've got the antenna mounted on top of a lighting stand. The lighting stand is only about 2/3 of a metre high at the moment, and then I've got this loading coil here which I can adjust. Above that, which you can't see at the moment, is the antenna, the antenna width, and then on the table there I've got the antenna analyzer. So the coax goes into the side of the or the base of the antenna there, which makes it convenient to feed when it's on top of the light stand, because the coax connection is at right angles. And then we'll take a look in a minute at what results we get on the Rig Expert's antenna analyzer. Now I've chosen 20 meters to do the test because 20 meters is usually active, and it's a band which usually get fairly good results on with shortish antennas. 15 and 10 are pretty close at the moment, and 40 meters the efficiency of the antenna drops off, so 20 meters would seem to be the sweet spot to do these tests with. Let's do a test now, see what happens. And there we are. You see, that's resonated very well at 20 meters with just the antenna on the light stand. And the light stand is, I've hired it a bit, it's only about a metre high. But I'm going to just show you something else. Let's do this scan again. This time I'm going to touch this. You see how completely unstable the system is. And that's because the whole system is resonant. Everything is very, very touchy. Now, interestingly enough, that really demonstrates in a dramatic way common mode problems on coax. As soon as you touch the coax, things change if you don't have a choke. Now, this is an exaggerated demonstration, but the principle is the same. The outside of that coax cable from your dipolar antenna can be quite live, and that's why you can get erroneous VSWR readings. As soon as you apply a choke, a line isolator choke, things clean up and they start to make sense. And that's the next thing we're going to do in a minute. We're going to now put a line isolator on that coax line, and just to see if it makes things less sensitive. Now I've inserted a line isolator, as you can see there. It's a line isolator I use on my HF transceiver, but I've taken that out of circuit and put it into this circuit. So let's see what happens now. Well, there we've got resonance on 20 meters at the bottom of the band. Let's see what happens if I touch this now. Absolutely nothing. You see how well that has isolated the coax. Now I'm having to make do with all sorts of bits and pieces to hold the coax cable up to stop it pulling the analyzer over. But let's just repeat the scan here. And you can see that it's definitely resonant on 20 meter band. And if I do a scan again, let's get a scan in, and holding that, nothing at all. Now, what I'm going to do now, whoops, is to touch this side of the choke. In other words, what we thought was the live side, or what was the live side, and just see what happens. Touching that now. See how live that coax cable is on that side. It's quite incredible. I'm sorry about the sunlight on the display here. It's not the best, but I hope you get the idea. I wanted to see whether I could make any contact with stations while operating inside the conservatory, or the aerial inside the conservatory. So I put it on the air yesterday and tested reverse beacon. I put the results on the screen now, and as you can see, had quite a few reports and not bad signal strengths, considering I was operating 10 watts from indoors. Unfortunately, today the band is totally dead. Even 100 watts didn't result in any reverse beacon reports on 20 meters, so the band is totally closed. Here's the system installed in garden, and as you can see, it makes quite a nice, tidy installation. So let's try and explain now what actually is happening with this antenna. I think the first thing to understand is that the lowest VSWR doesn't necessarily coincide with the resonant point of the antenna. Very often the resonant point is not quite where the VSWR is, the lowest VSWR is. But what we want to do with any antenna is to get maximum power into it. And the point of maximum power is where the lowest VSWR is. Now that may be quite where the resonant point is. That doesn't matter. If we go for the lowest VSWR, we get maximum power transfer. Now in this particular antenna, we've basically got a loaded quarter wave, base loaded quarter wave above the feed point, and we've got some metalwork below the feed point. Now that metalwork is basically the light stand that we talked about earlier in this video. There's no guarantee, of course, that the metalwork is all connected in your particular light stand. I think mine is. You could actually replace the metalwork, the light stand, or supplement it with a bit of wire dangling down from the earthy side of the feed point, the sheathing of the coax. But let's assume that we've got enough metalwork there that makes it work, and in this particular case we have. And we know that we get a low VSWR. But it doesn't actually make sense, because we know, or we believe, that we've got a quarter wave resonant antenna above the feed point, and we've got something which is certainly shorter than a quarter wave on 20 meters below the feed point. We'd normally expect to have a quarter wave length of wire or something like that to make the whole thing resonant. Now bear in mind that as soon as you load a vertical antenna, in other words you make it shorter, the impedance drops. In this particular case, we've got a quite heavily loaded vertical element, the element that the inner conductor of the coax is connected to. It's quite a lot shorter than it should be. That means to say that it's a low impedance. Now, if it's a very low impedance, you'd expect to see a mismatch. But what's actually happening in this case is we are actually feeding the dipole antenna. Imagine it's a vertical dipole antenna. We're actually feeding it below the center. So what actually is happening here is we're actually adding inductance to the upper part of the antenna. In other words, it actually would appear to be resonant at a somewhat lower frequency, but we've then added the metalwork. The metalwork and the antenna represent half wave vertical dipole, but because we've got far less metalwork below the feed point than above, we've actually moved the feed point away from the centre. And as soon as we move the feed point away from the centre, we start to raise the impedance. So what we end up in this particular case with, you could call it fortuitous, but anyway, what we end up with is an increased impedance which matches the coax cable. Now, in any antenna like this, you've got reactance, you've got inductive and capacitive reactance, but also you've got an increase in impedance as you move that feed point away from the natural centre point of the antenna, the electrical centre point. So, in effect, what we've done is we've got a compromise. We've got a bit of reactive component there, a bit of capacity, a bit of inductance there, but we've also increased the impedance, the natural impedance of the antenna at that particular point. And so we end up with a fairly good match. And it's one of these things that it's almost impossible to model it. You'd need 3D modelling to actually study it and recreate it. But it's a classic example of suck it and see. If you understand basically what is likely to happen, and then you mess about with it and see what does happen, you very often get some good results. And this is something which I call the magic of antennas. It's magic, isn't it? We don't actually know what the impedance is, we don't know what the reactance is, but we do know that we're getting a low VSWR. And we've also demonstrated that it's very, very, very important to have a line isolator. As soon as you put a line isolator in circuit, everything starts to make sense, everything becomes far less touchy. Of course, you can erect this antenna in a much more conventional way using a radial. This is a radial here that I've got, which is just less than a quarter wave on 20 metres actually. It's I think it's about 13 or 14 feet long, and I've got a line isolator there which isolates the coax from the antenna. You remember I did that in the video earlier on. It isolates the cable, and then I've got this coax cable, and this coax cable goes to, would you believe, in the tree here, a zoom antenna analyzer. And this is what we're going to use to do the measurements with. This is set up for 20 metres. Press this, and you should start scanning. I hope you can see this. See, you've got a pretty good resonance there, and that's just working in the normal way, vertical with it's a shortish radial, so probably that's helped to raise the impedance anyway. Now, interestingly enough, without changing the radial, I simply telescoped the antenna down a bit to 18 megahertz, and I think you can see I think you can see there quite clearly that we've got resonance on 18 megahertz, even though we haven't changed the radial. All we've done is telescoped the antenna down. Well, it didn't work on 15 metres, it was pretty horrible. So it does mean to say that if you've got a radial that is halfway between one band and another, particularly between 20 metres and 17 metres, because they're quite close together, those bands. If you have a radial that's sort of halfway between a quarter wave on one and t'other, then you get a reasonable VSWR. So basically, with that single radial, which is around about 13 or 14 foot long, you get a good match on both 20 metres and 17 metres. So there we are. An interesting exercise that you might want to play about with. These lighting stands don't cost much, as I think I said, they're only about £15 or so. And they are fitted with a thread which will fit straight into the base of the Yaesu ATAS-25. It also happens to fit nicely into the base of your IC705 or anything else that's got a camera thread. The thread on the light or the thread at the top of the light fitting is exactly the same as a thread on a tripod, but it just so happens that these lighting stands are far cheaper than a camera tripod because it hasn't got all the various adjustments, and you can get a decent height. So, as usual, thank you for your support on this channel. I hope it's proved interesting. It's been an interesting exercise for me, actually. Didn't quite know what to expect, but I was pleasantly surprised. And I hope that it's given you the encouragement to go outside there and do a bit of experimentation, even though you could actually operate this from indoors. Really, you need a conservatory or something like that. But it is possible to radiate a signal from quite an enclosed space, so give it a try. Again, thank you for supporting the channel, it's much appreciated. Don't forget to press the subscribe button, that tells us that we're doing the right thing. In the meantime, you enjoy ham radio, and I'll look forward to seeing you, as usual, in the next video. Bye for now.